Okay, let's talk about Ohm's Law. The purpose of this video is just to give you an introduction to Ohm's Law. By no means is this going to be an extensive lecture on electricity, as obviously that's a huge topic. This would be applicable, this video would be applicable for those of you who are just being introduced to the concept of electricity. Maybe you're working to become a electrician. Maybe you're taking a basic science class, physics class, whatever the case is, and you just want to review the concepts of Ohm's law. So that's really what we're going to be doing here. Before we get started, let me introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher. And if you're interested in any math help from my instruction, I'm going to leave a link to my learning program below. So you might be thinking, well, what's a math teacher teaching electricity? Well, I also have an engineering background. In a former life, before I taught math, I ran engineering plants in the military and the Navy, and also worked in chemical engineering. So I got a pretty extensive engineering background. Of course, mathematics is the language of engineering. And Ohm's law, again, is just one of these things, even if you're uh, just curious what it is, it's a good thing to know. Okay. All right. So I want to do my best to obviously explain some of these concepts. Again, if you are an expert in this, or maybe you're teaching this at a higher level, you know, um, you know, please overlook any, little details I might be leaving out. Of course, I'm not going to be able to get everything Um, in this one video. Also, I mostly do math videos, but do some science videos as well. So hopefully consider subscribing and liking this video. But with that being said, let's get into Ohm's law. So there's a lot of different ways we see this law written. Okay, now Ohm's, it was a person that lived in the 1800s. Okay, a scientist. Okay, so this law, all right, and in science, a law is a principle that was named after this person. So really think of it as a formula. Okay, so it's a formula, some sort of relationship, some sort of principle that guides us with electricity. It's very, very important. And here it is right here. It's E equals IR. A lot of different ways, well, not a lot, but there's a few different ways you can write this. This is a very common way of expressing Ohm's law. E equals I times R. Of course, those variables mean nothing to us unless we give them some meaning. So let's go ahead and do that now. And I'm going to walk through this step by step. So E is our voltage. So you're probably thinking to yourself, yeah, why didn't they put a V here and they put an E? Well, voltage can also be referred to or thought of as electromotive force. All right, so we don't really call it electromotive force. We think of it as voltage, but that kind of just stuck in terms of that E, in terms of the formula. Okay, so when you're thinking of E, you're thinking of voltage or volts or V. All right, I is our current. All right, so current or amps, all right, is how that's expressed. And so you're probably saying again, what is this I doing here? How come they didn't put an A? Good question. But that I refers to the intensity. Okay, so these are just kind of nomenclature that was used a long time ago, still used today. Again, when it comes to electricity, it's good to have a couple, two, three, four different ways thinking about it. Okay, I'm going to talk about that here in a second. You want to find a model that you understand about electricity or terms. As long as you understand the formula and how to use it, that's really the main point here. And then R is resistance. Okay, so resistance is measured in something called ohms, and here is its little symbol. So we have volts, amps, and ohms. Okay, so voltage, current, and resistance. All right, so how is this? What does this all mean? Okay, well, obviously there's this law, okay, Ohm's law, which says voltage equals current times resistance. All right, so that's really the main concept here, right? Voltage equals current times resistance. This is Ohm's law. Again, the algebra, the formula, could sometimes give some people a little bit of trouble. Of course, being a math guy, I have an extra motivation to clear up any of this formula confusion. And when this is taught, by the way, Ohm's law is taught, to let's say people are going into the trades or really don't want to think about the algebra because it confuses them, and I understand that. There's different little shortcuts and different ways you can think about it. There's like a little triangle. You could think of this law, but I want to teach you some basic algebra. Literally, it will take you like a minute, just so you can just work with these formulas confidently. Okay, it's important, I think, that you should know some basic algebra. All right, so let's get into electricity. All right, we're talking about voltage, current, resistance. Well, what does this all mean? Well, we're talking about electricity, obviously, and a good way to think of electricity in terms of all these different concepts, voltage, current, and resistance. How are they interacting with one another? Obviously, they are, we don't take one all by itself. We're not looking at voltage. There's something going on, there's current, there's something else going on, there's resistance. We're talking about basic electrical circuits. But before we kind of get into that, let's just think about electricity. And I think it's a great model is to think of electricity like a water hose. Okay, so electricity is like a water hose, and this will help give us some context with what voltage is, current is, etc. All right, so everyone knows what a water hose is. So here is a little water hose, and let's just talk about voltage. Okay, so voltage is like the pressure that's pushing this water. Okay, so you can think of voltage as pressure, right? That's a good way of thinking of it. Here's our hose, there's pressure, and here's all the water. Now these little water droplets here would be what? Really, we're talking about electrons, right? So voltage is pushing the electrons, if you will. So it makes electrons flow. That's voltage. Simple as that. Okay, so let's just keep with this water hose analogy and move on to current. Okay, so current again is measured in amps. This was our I. Okay, our voltage here was our E. So current is the rate of electron flow. Okay, and you can kind of think of current as the size or the diameter of the hose. Okay, so if you have a smaller hose, you can think about what's going to be happening to the rate of the electron flow. It's going to affect it. Okay, we have a huge hose that's going to have a bearing on the rate, how much is flowing through that hose. Okay, so current. You can also think of this in terms of a wire that you're creating a circuit with. Something like a lamp plugs into the wall, the diameter of that wire, right? I'm sure everyone has seen little extension cords that have like a little tiny wire to it, right? You plug it into the wall. Let me ask you, do you think this has a bearing on how hot this wire is going to get versus a wire that is really big and huge? Well, yes, it does, okay? And this has to do with current. It has to do with all these different things, but a lot of these analogies have kind of have somewhat of a physical correlation to it, okay? In terms of the diameter of a wire, current, voltage, etc. Anyways, I don't want to digress too much, but that's a good way of thinking of current is the diameter, the size of the hose, okay? And that is, again, the rate of electron flows, okay? How many electrons are passing through, how fast that's happening. All right, and then lastly is our resistance, which is measured in ohms. Generally, you'll see this little symbol right here. That's omega. It's a Greek symbol. Okay, so you'll see that probably the most frequent way resistance is measured. It's measured in ohms, but it's written either with the R or this omega symbol. So resistance is kind of like, what the word is saying, that there's resistance to this flow. So good way of thinking of that is here in our water hose, if we had like sand particles, right? If we had a few little bits of sand, that's not going to impede our flow too much. But the more sand we have, the more resistance we have. So resistance is a flow inhibitor. Okay, so how more resistance, that's going to inhibit the flow. Okay, which of course is going to have an impact on the current. And the one thing about this, all right, in terms of resistance, voltage, or current, one is going to affect the others. Okay, so you mess with the resistance, everything else is going to change. Okay, in a circuit. So let's kind of put this together, these concepts. of a basic circuit in a model here. So let's look over here to our left, and let's just use this water hose concept here for a second. And let me go ahead and just center this a little bit better. All right, so here is our little water spigot. Okay, something that we just, put our water hose on, like city water pressure, right? And we turn on the water, whoop, there's our pressure, right? So the more we turn that valve to increase the pressure, that's our voltage, right? So it's pushing this water around, and the hose size, the diameter of the hose size, okay, that's going to be our current. That's going to affect our current, which is going to be in amps. Okay, so our water hose can be very large, it can be very skinny. Okay, just think of kind of what goes on with this if you had a super small, like a straw size hose versus something like a water hose that like the fire department uses, right? You're gonna be able to have a lot more water flow through that hose versus like a little straw type of deal. Okay, depending on what water pressure you have. And then of course any sand in the line in this water hose is going to be our resistance. But let's look at this now. Let's take this water hose model, which is an excellent model, and now really kind of try to look at this in terms of an electrical circuit, because this is what this is all about. Now, again, this is a very, very basic video. We're talking about direct current. You can talk about AC, and this is going to be, alternating current. These models kind of vary differently. So again, if you are, teaching this stuff, if you know more than what I'm saying, listen, good for you. Honestly, I'm just trying to really, focus this on an introductory level. So I'm going to be missing, well, I guess what I'm saying in a long way is I'm going to be, not covering a lot of important things. So if you really want to continue to learn about electricity, I would take this to the next level. But let's just go ahead and just keep it super simple. And now let's think about this basic electrical circuit. So here we have a battery. Okay, and this battery is going to produce voltage, right? So it's pressure, right? It's going to produce electron flow, and so our electrons are kind of flowing through the wire, the circuit, okay? And the wire, the ability of this wire, it's the diameter of it, if you will, okay? That's going to be our current, right? That's going to be our electron flow, the rate of electron flow, excuse me. And then it's going to go do something, right? I mean, electricity, we want it to serve a purpose. So here, this electricity is going to light this light bulb up, but it's going to, by doing that, it's going to run into some, resistance, okay? It's going to have to do some work here. So here is our light bulb. That's going to cause resistance in this circuit, and that's going to be measured in ohms, okay? And then, of course, this is going to return back to the voltage source and just kind of do this loop. So really basic electric circuit here. So this is what we're talking about. We have something that's going to cause resistance. It could be a light bulb. It could be a coffee machine, anything, right? It could be a curling iron, a blow dryer, whatever. Then you have a voltage source, which we're going to use a battery for our examples here. Okay, and then we have our wiring that goes through it, and this is going to be our current. All right. So with that being said, let's go ahead and actually apply Ohm's law. But before we do that, as I promised, let's just review some basic algebra. Don't panic. This is basic algebra, and I want you to be, comfortable with basic algebra, right? Because I think what gets people in trouble with Ohm's law, outside of just not understanding the concept of voltage, current, resistance, is the algebra. There's no need to panic, all right? So let me just give myself some room here. So here is a basic algebra equation, 2x equals 10, all right? Now this 2 and this x together, this means 2 times x. And in algebra, x is just a variable. It just means some number. So if I asked you 2 times what number, okay, is equal to 10, you would say, oh, well, that number's 5, and you would be correct. But in algebra, when we have a number in front of an x like this, and we want to solve for this x, what we need to do is to get the x by itself, right? That's our objective. is to get the x by itself. Over here, you can see we have this 2 in front of the x, 2 times x. So what we have to do in algebra is divide this 2x by a 2, because 2 divided by 2 is what? Well, it's 1. Okay, so now we have a 1x over here, but we never really write 1x, we just write x. Okay, but here is the main thing you need to know about algebra. Main principle about algebra is whatever we do to one side of the equation, all right, we have to do this exact same thing to the other side. I want you to think of an equation in algebra like a seesaw or a teeter-totter, right? It's in balance, it's in scale, all right? So we can't put this, put anything more over here because the scale is going to tip. We have to put the equal amount over here. We have to always keep things in balance. All right, so let's go ahead and solve for x in this equation. We know the answer is 5, right? 2 times some number is 10. We know our answer is going to be 5. So I divide both sides of the equation by 2. And here, right, I had to divide the left-hand side because I'm trying to get the x by itself. All right, so now I get the x by itself because 2 divided by 2 is 1. And this is a 1x, but we just write it as x. And then 10 divided by 2 is 5. So there is our solution to this basic equation. That's pretty much all you need to know to handle Ohm's law, okay? I don't want you to get confused. And I think that a lot of people get in trouble when they have like rote memory. I don't know if you know that word, R-O-T-E. It's just basically like learning from a flashcard. You're just trying to keep it in your memory. It's better to learn the concepts than to just try to memorize stuff because, you're using a lot of bandwidth up there. It's just good to just know this stuff. All right, so let's go ahead and take a look at another example. Y times x equals 10. All right, so let's say, hey, I want to know, I want you to solve this equation for x. In other words, I want you to rewrite this equation as x is x equal. Okay. In other words, I want you to get rewrite this situation, y times x equals 10, in a different way, such that you have x by itself on the left-hand side. This is equivalent to doing this same problem we did over here. Okay. Now, if you look at it, it's the same problem, but this y was where the 2 was at, right? Okay. Well, just basically follow the same steps. So how do we deal with this? We divided both sides of the equation by 2, all right, so to get x by itself. We're going to do the exact same thing over here. To get x by itself, all I have to do is divide both sides of the equation by whatever's in front of the x. In this case, it's a y, all right? And so y divided by y, anything divided by itself is 1. So now we have x is equal to, let me write this a little better, x is equal to 10 divided by y. All right, so this equation here is equivalent to this equation in algebra. We're just writing this differently, okay? So this is the key to working with Ohm's law. So let's go down here real quick. And these are different variations of Ohm's law. E equals IR, very common way of writing it. And then we have volts equals IR. It's another way. You can also see volts equals amps times ohms. Okay, but basically it's still voltage equals current times resistance, right? So let's kind of mess around with this E equals IR here. All right, well, basically to show you how to work with this formula real quick, okay? And then we'll do a couple examples and we'll wrap up this video. So let's say I wanted to write this formula in terms of R. R equals, okay? Don't worry about the resistance and current. I just want you to think about these variables, right? Don't think about what they mean for now, okay? So if I wanted to get R equals, here I have E equals, right? E equals all this stuff right here, okay? That's what I have. But I want you to write R equals whatever else is in here. Obviously, it's going to involve an I and an E, okay? So how do we do that? Well, the way we do that is this, all right? So we're going to want R equals. The best way I would suggest doing that is let's write the IR. Okay, the left-hand side here, E, is equal to the right-hand side, IR. So if the left is equal to the right is going to be equal to the left. So technically, it's not a problem that we can write this equation IR equals E. Okay? Do you understand? So the left is equal to the right's equal to the left. Okay? So normally this doesn't look, kind of fancy or doesn't look kind of correct because, normally we just have one letter on the left-hand side, not these two variables. But I'm trying to rewrite this in terms of R, okay? All right, so IR equals E. All right, now here, I want you to think of this as 2x equals 10, right? Remember what we did here? And I'm trying to get R by itself, all right? So if you look here, the I is like in that 2 spot, and then the E is like where that 10 was at. So I had to just divide both sides of the equation by whatever was in front of the variable that I'm trying to solve for, okay? You understand that? So hopefully you're kind of getting this. So to get R by itself, if I just divide both sides of the equation by I, all right, now I can get R by itself. So R is equal to E divided by I, okay? And of course, this is Ohm's law. This is Ohm's law. You're just rewriting the relationship between voltage, current, and resistance differently, depending on what you want. If I'm looking for the resistance in a particular problem, I need to rewrite it in terms of R. If I'm looking for the voltage, it's already written, okay, for E. I need E, and this equation is already set up for it. And of course, if I need the current, I need to rewrite this in terms of I, okay? All right, so hopefully this is, helping you, the basic algebra. Again, if you already memorize Ohm's law in a particular way, then stick with what works. But I think, wherever, even if you're, studying electronics, it doesn't make a difference. You should know some basic algebra. This is very, very fundamental stuff. So even if you memorize Ohm's law differently, I think it's important that you, have some basic algebra concepts behind you as well. All right, so with that being said, let's do some quick examples and then we'll wrap up this video. All right, so here is a diagram of a circuit. So we have a little battery here, okay? It's a 12-volt battery, okay? So that would be our E, excuse me. And then we have a light bulb here, okay? And that's, of course, going to cause resistance in our circuit. And that light bulb has a resistance of 6 ohms. So the question here is, what is the current of the circuit? What is I in this case, right? All right, so in order to figure this out, we need to go ahead and take a look at our Ohm's law. Okay, so just, it's always good to just memorize one equation, not too many equations, just one form of it. In this case, we need I, right? We need to know what I is equal to. And of course, you can see I already done the work here, but here E equals IR. We can write this as IR equals E, as we discussed. The left equals the right equals the left. And now I can just go ahead and divide both sides of the equation, okay, over here by I, okay, or sorry, by R, all right? So if it helps, IR, let's just break this out a little bit further, all right? Now, I times R in algebra is the same thing as R times I. They mean the same thing, okay? So that equals to E. So if this helps with that little model, 2x equals 10, all right? If that helps you understand that better, that's fine. But to get I, and that's what I need, the current, right? I got to divide both sides of the equation by R. So I is going to be equal to E divided by R, okay? All right, so let's go up here. I equals E over R. That is the form of the equation that we need. And now we just plug in our information, okay? So what was E? What was the volts here? Okay, we just go back up. We need the volts and we need the resistance. So remember, this battery here was 12 volts, okay? And the resistance of the light bulb was 6 ohms. So we just plug them in, okay? 12 volts divided by 6 ohms. And I'm going to spare you all the physics and everything, all the concepts between the units of measure. It is important that you do put the proper units of measure here because you can be, working with different, you know, uh, forms or bigger values, or I don't want to kind of go too far into it, but you need to be sensitive to units of measure. But volts over ohms, when we do that, we get amps, right? So 12 divided by 6 gives us 2. Okay, so I is our current. So the current in that circuit is 2 amps. All right, so let's move on to another example. Okay, same kind of circuit. This time we have a battery that generates 24 volts, and the current of this circuit is 6 amps. Okay, so now obviously I'm looking for the resistance. So what's the resistance of this light bulb? So I need to, of course, when I'm thinking of Ohm's law, E equals IR, I want to rewrite this formula, okay, in terms of R, because that's what I'm looking for. Okay. All right, so if you want to go ahead and try this problem on your own, I would always encourage you to do that. Pause the video. But here is our work. So here again we have E equals IR. It's our main equation. We need to rewrite this, or in algebra we kind of would call this, write this in terms of R, because that's what I'm looking for. I'm looking for the resistance. And when I do that, it's going to be R equals E over I. Okay, so we already talked about how we can think about that basic algebra. So this is the form of the equation that we need. And then E, again, is voltage, and I is the current. So let's go back and review. The voltage of this circuit was 24 volts, and the current was 6 amps. So we just plug in our values. Got to make sure you don't write your work out, by the way. Don't rush through the problem. Another thing that people who are learning this or applying it, you're just kind of doing this mentally in your head. You can do that if you don't have any paper or pencil, but when you're really learning this, write out your work, write out the steps. It will help reinforce all these formulas and concepts, right? So we have E, that's our 24 volts divided by 6 amps in this particular circuit. And that 24 divided by 6 is 4, but 4 what? 4 ohms. That's the resistance of the light bulb in this problem. Okay, let's wrap this up and do one last problem. Okay, so here's the situation. We have a circuit, we have a battery, but this time we don't know what the volts are. Okay, we know the current. Okay, the current of the circuit is 5 amps, and we know the resistance is 8 ohms. Again, the voltage, the current, and the resistance, they all work in harmony. Okay, they're all to be considered as one kind of concept. One is going to affect the other. All right, so if I have the amps and if I have the current and the resistance, I can get the voltage, etc. Right? As long as you have 2 out of 3 of any of these things, you'll be able to get the other missing part. So here we're looking for the volts, okay, of this circuit E. So we're going to break out our handy dandy Ohm's law, E equals IR. I need E, but guess what? How lucky are we? The formula is already written in terms of E. There's nothing else to do because that's what I need to get, right? So E equals IR. I'm going to plug in my I is my current, right? In this case, again, let's just review. The current of the circuit was 5 amps and the resistance was 8 ohms. All right, 8 ohms and 5 amps. So I'm going to plug in 5 amps for my current. My resistance is 8 ohms. All right, so let's make sure we put in the units of measure. And then our answer, amps times ohms, is going to give us what? E. It's going to give us volts. So the voltage, okay, is going to be 40 volts in this circuit. Okay, no way that this video was 10 minutes. I have no idea how long it is, but I tried to go as quick as I could, but slow enough to make sure you get the major concepts. I mean, the value of watching this video hopefully was that you learned something that cleared up any confusion. You know, if you just, like anything, if you're going too fast, you're not going to get it. You're going to miss something. Now, of course, I didn't cover everything. There's a lot of little details and even bigger concepts that you can go into about electricity. But in terms of the real basic fundamental essence of Ohm's law, it is, I think the main thing is remember don't confuse yourself with too many different formulas. You need to have a good fundamental basic model of what electricity is, okay, like that water hose model. It's a really popular one. I think that's a great one. But if you know one formula, you can solve. Here we have E, okay, but if you know some basic algebra, you can always rewrite that in terms of I or rewrite that in terms of R, okay? I would try to discourage you from just memorizing, all right, the formulas, all right? Get comfortable with the basic algebra and then practice this stuff. Of course, some of you are might be electricians or whatnot, or electronic technicians are going to use this on a daily basis, so you'll like know it. You can teach it and know it way better than most people. But some of you might be taking a basic science class, or some of you out there might just be interested in what Ohm's law is. But with that being said, I definitely wish you all the best. Hopefully, this video, was interesting. And if it was, please consider smashing that like button. And, if you want to learn math from me, okay, if you have a need to understand basic algebra or beyond, definitely want to check out my learning program. But with that being said, I definitely appreciate your time and have a great day.